Okay, so my name is Gilles. I'm Gilles Garcia. I'm the director of the Y communication for Xilinx. And today I will present, we will do a duet with Tanyana from Ixia. So what I would like to do is first of all to introduce what we'll be talking about. So 400 gigi, 25 gigi, and why is it important to have partnership between leadership test equipment vendors and technology providers. And today we will both talk about what are the challenges, what are the solutions, and what are the products that we are delivering in order to help the OEMs and the community to adopt the 400 gig and the 25 gig. So, who is Xilinx? Who knows who is Xilinx on the audience? Okay, a few. Okay, good. We need more. So Xilinx, we are the leader on the FPGA, which is Field Programmable Array, which is reprogrammable chips that allow to cover a broad set of range of applications from consumers to aerospace and defense, and of course telecom equipment. So today I will be representing Xilinx, and let me turn to Tanyana so she can explain and proceed with the presentation.
Okay, let me try this one out. Can you guys hear me okay? Thanks, Gilles. My name is Tanya Baldwin, and welcome, good afternoon, and thank you for coming and being here today. So Ixia has solutions that address industry pain points in areas of application performance and security resiliency. We have solutions that will validate, secure, and optimize your network. So today I want to talk about two new Ethernet speeds. Why two, you guys are asking? And why 400 and why 25? One seems really fast and one seems not so fast. Okay, well, it's really an easy answer. We'll address it in three factors. We have more users, increased access rate, and increased services. So more users. We have new users coming to the Ethernet party, automobiles. We currently have IEEE programs, or projects, excuse me. There's at least 4 of them that are addressing automotive Ethernet. So we have car makers, we have their suppliers, no pun intended, driving the direction of these projects. Of course, Ixia is there, participating as well. We have wearables and Internet of Things. These are the top 2 out of the 3 highlights from the Consumer Electronics Show earlier this year. Speaking of wearables, I've got my Fitbit One tracker on. I've been wearing it for 2 years, and looks like today I've got over 7,000 steps. So
7,000 steps. Remember this number.
Oh yeah, right. We'll do a quiz at the end. That's just how we roll. Well, all these users are making us put up more data centers up there. And speaking of data centers, the next gen data centers is going to be different. We have underlying technologies like the QSFP28. In case you missed the memo, they're all over the floor today. And you have 10 gig technology that's migrating to 25 gig technology. So you basically have a QSFP plus form factor that is now QSFP28, even though there's still 4 lanes, but each of these 4 lanes is now running 25 gigabit instead of 10. So guess what? You're getting like 2.5 times the traffic density. So imagine you're coming in, driving in here, and your car all of a sudden drives 2.5 times faster. That's pretty cool. So let's see, with 25 gig, anything else that we can add to the 25 gig E?
No, I think it's new emerging markets and new emerging standards, so we'll talk about it later on.
25 is like the new 10 in the data center. Increased services. I did a quick search and I saw for, I think, the Google Android users, there's 1.3 million apps you can download by whatever, and that was from June of last year. And there's 1.2 million apps for the Apple iOS users, and that was, 9 months ago, and who knows how many apps are available today now. So I really like this quote. This was from the Wall Street Journal earlier this month for the World Mobile Congress in Barcelona, and it says, "People around the world have an insatiable demand for connectivity and will continue to pay for the ability to stay connected wherever they go." So 2 things I like about this quote. First, insatiable demand. And the second thing, more importantly, they are going to pay for it. Okay, so 400 gig and 25 gig challenges. We say for operators and OEM, but we should add companies like Google, Microsoft, Facebook, Amazon, in what we traditionally call them as operators. These companies should be included as well. So with these challenges, the industry must answer to this demand explosion, I think, timely and with foresight. So you need to have proven test technology, to make sure that you have successful rollout of your 400 gig E and 25 gig E. Let's see, the IEEE and also the industry consortium are specifying the new physical coding sublayer, right? The new 25 gig electrical channel characteristics, the optical PMD. So these new building blocks need to be validated within your network design. We talked about security a little bit, and that's one of the industry pain points. You read in the paper, you always read about some security breach, almost every week, and some high-profile breach. And so you want to make sure you secure your network, and you want to make sure that your test solution could simulate current real-world threats, so that you could find the weaknesses in your network. And you want to do that before someone else who's intending to do harm finds them. And lastly, when you're network operations, you want to make sure that you can monitor and optimize your network so that you can ensure service level agreement or application delivery. Okay, all right, this is the really fun part for me because these are the two products that were shown at OFC this week. And our booth is just right there. So if every turn around, it's like down this aisle, 2 booths back. And you can go see the hardware demo. We have the 400 gigabit Ethernet test solution. We announced this last year, June of last year. So we're the first one to have this. Our system has CFP4 front panel interface. We have implemented 16 lanes of 25 gig electrical, and that's called Kadawi. So let's not argue about how you say CDA UI, all right? So you guys are now the cool kids. It's called Kadawi 16. Okay, and we've implemented pre-standard 400 gig physical coding sublayer. This is a really cool number. If anything else you remember today, I want you to remember, no, not the 595, 237, 600. Just kind of round up, 600 million. So with 600 million packets per second, what does that mean? So at 400 gig E, Ethernet minimum frame size of 64 bytes is 600 million packets per second.
Wow.
Thank you.
Oh, my pleasure.
So the Ixia solution could transmit at line rate. We're creating unique packets. 600 million packets per second. Come on, you guys. Wow, again, come on.
Remember this number.
You won't hear it 600 million more times, just maybe a few more.
And
okay.
It's euro, it's not US dollar. So it's
about
even
1-to-1 now. You know that, right?
Yeah.
Okay.
I know.
So either way, yeah, okay. All right. So anything else about 400 gig I want to talk about? It's really amazingly fast. 600 million packets per second. Okay, I got it. The next item is our being announced this week. Actually, we did a press release last week. Our 25 gig Ethernet product. So for the first time, we're doing public demo. So today, you guys can go check it out. I know the wire rate number, 37 million, is not as impressive as 600 million, but guess what? Once you see the demo, you could say, hey, I've seen the world's first and only 25 gig E test solution. That's pretty cool.
Wow.
Thank you. I like that accent. Is that okay? Oh, by the way, when you go see the demo, tell them that Tananya sent you and said, hey, I heard that there's this really cool, got 25 gig E t-shirt, so make sure you get one of those. Let's see, 25 gig, it's based on our 25 gig E and 50 gig E consortium PCS implementation, and this is the same as the initial draft of the IEEE 802.3 BY. We have QSFP28 on our front panel. And let's see, there's 37 million we talked about, and any cool thing? Anything else?
I think I'm excited to see what's making this capable.
Okay, just another quick brief highlights. We talked about this already. We could generate unique packets at
600 million
packets per second.
packet per second.
Okay. Okay, very good. All right, we can also receive at line rate, and we're doing this and we're capturing it to do real-time analysis. And this last third bullet is really important because this is an independent PCS implementation. And when you're doing interoperability, it's not as compelling to interoperate with yourself. Maybe that defines a definition somewhere, but you know, it's two different implementations. We got the Xilinx implementation and the Ixia implementation on this. Okay. So we talked about how the industry must answer to the demand explosion timely and with foresight. So timely is time to market. You know, how cool is it to be here a year later? Not as cool. So you want to be right where they need you, right where your customers need you. You want to be there for them, you know, to test and prove out the 25 gig or 400 gig technology. Well, to make this happen, of course, you know, all the hardware guys and system guys out there, heat, space, you know, these constraints we all deal with. It doesn't matter where you work, your hardware, you have these constraints. And so we talked about 64-byte packet at line rate. That's 600 million. So if we were to go down, we can go below the Ethernet frame size, by the way. We can go down to 49-byte. Okay, quick math. All right, that's 700 million. And that's 725 million packets per second. But we could do that as well with our platform. So our solutions are FPGA-based, okay, and that gives us the flexibility to, as the standards evolve, make the changes. You know, it's not ratified yet, neither the 400 gig E or the 25 gig E. As things change or take shape, we can make those adjustments. And when you do have this chip that has 16 25 gig SerDes on it, so, you know, and that Q accent, of course we have to use this part on our board.
And it's part of the package. So thank you very much for this introduction. And again, a couple of numbers just to remind everybody. 600 million packet per second, 37 million packet per second for 25 gig. And everything doable thanks to two things: Xilinx technology and a lot of hard work and all the IPs that Ixia has developed for their systems. So let's talk a little bit about the challenges that this technology allows to address and we are capable to answer in those space. So I will start by the left, the 400 gig. So at the system level, you have the system capacity which is evolving from terabits to tens of terabits. And so as such, you need to have a flexible, capable technology that can evolve with those demands, but still fitting the constraints that you are also facing on those systems. Power, cost, to not say the least, and as well being able to test those systems. And so to test those systems, you need to have test vendors that can be the first one to be able to deliver those type of capacities and being able to help the system vendor to be first to the market. If you are going one step below at the line card level is even worse because you have power constraints per line card and which are even lower than what the system constraints are. Memory, you have to have a lot of memory very often around the chip or inside the chip to be able to deliver the capabilities and to handle all the features that the tester companies want to do, like Ixia. And again, 400 gigabit per second with 49-byte packet, that's impressive. And Xilinx technology allowed Ixia to be able to deliver those. So if you are looking at the 25 gig, and we are talking about what Ixia has been able to implement here. 25 gig, this is mainly a data center driven technology. So which allow to double the capabilities from the NIC card or server to the top of the rack switch. But on the data center, power constraints are even worse. So being able to have very low power at the chip level, being able to handle 25 gig with few links or with a lot of links when you are talking about the top of the rack switch, that's very important to have this type of technology. When you are at the port level, all the features that you need to implement into the NIC card, TCP/IP offload, accelerations, all require the very high capabilities and flexibility that Xilinx technology deliver with the current platforms that we have. And all of these has helped Ixia to be first to the market with those two platforms. So if we are looking at other challenges that we are also seeing on those systems, more on the telecom side, So we have the challenge to be able to discuss with or to talk to all the optical modules, including CFP2, CFP4s, coherent optical module, CDFP, CWDM4. And we can do that because we have the right transceiver technology at the high quality, the right rate, from a very low rate up to 33 gig rate per transceiver to connect directly to this technology. Standards are evolving. Taniana, you were mentioning that. That means we will talk about where do we stand in the standards. We are probably a year and a half away from the 400 gig standard to be ratified. And we are still able to deliver first to the market the single 400 gig chip capable in this industry. So looking at other challenges on the 25 gig side, latency. You have a lot of applications that are data center focused where you need to have ultra low latency. The 25 gig MAC PCS IP from Xilinx, we are very low latency, sub 50 nanoseconds. If we are talking about transceiver speed, Tanena, you have a comment saying 25 gig is the 10 gig, or equivalent to the 10 gig of the past. For the second time in the industry, you have a standard which is perfectly matching the transceiver capability, the transceiver speed. 10 gig 10 years ago, 25 gig today. And having the right technology with the right reach, the right quality to deliver these is very important on this space. And by the way, last but not least, standards. 25 gig, you are talking about the 25 gig consortium. You are talking about the 25 gig IEEE standards. So, and both of them are not yet ratified, and they are probably another year away to be ratified. And even though, thanks to the flexibility of the FPGA platforms, we can deliver pre-standard implementations and have Ixia developing their own implementation as well to make sure that they can have all the hooks for the test magic to be able to deliver the first to the market. So if we are looking at now more at the Ixia platform, so that's what is inside. A 28 nanometer, very efficient chip, connected to 4 CFP4s, 16 by 25 gig SerDes capable, lot of logic so that Ixia can implement its own magic and IPs into the FPGA, connect memories so they can have the packet stored or manipulated. And same thing for the 25 gig. 25 gig having a chip FPGA that can be used to have the FPGA, the test magic developed and very efficient into the FPGA.
We call it the pixie dust.
Yeah, I'm not sure I like it, but let's go with it. And in order to develop and to design those in a very timely fashion, you need to have a very efficient EDA tool. Our EDA tool is called Vivado. That's the Vivado design suite. And that has been a great improvement and great help for the Ixia team. Being able to improve and to have very efficient turnaround for the different bit streams applications. So did I miss anything on this slide? Yeah, two numbers. 600 million.
Thank you, yes.
And 37 million. So I think that, can I get a t-shirt?
There's a small.
Okay. Okay, thank you. So let's try to do better. So now let's talk about numbers. Terabit on a single chip. Xilinx announced a month ago a new generation called UltraScale Plus, based on 16 nanometer technology, that will allow a customer to deliver 800 gig and 1 terabit into a single chip. That's making, if I'm making the right calculation, 1.2 billion packet per second. Did I get right?
Math is not working.
So now we are talking about numbers. So, and this will be, this will allow a lot of connectivity, so up to 8 100 gig port connected. By the way, being able to connect to interlaken if you want to have a switch on the other side. So again, this technology will allow customers in the telecom space to do a lot of integration. Not talking about the integrated memory for all the statistics and all the test features that you want to be able to do without having to go external memories. And what does that mean, not using external memories? Less power and less cost.
Room, yeah.
So high integration for 400 gig 800 gig applications with hardcore, Max, and Interlaken. So again, we are talking about real cool technology. And cool technology, it's not enough. It's technology that will start sampling end of the year, that are pin-to-pin migrable from the current technology that we have in production. So is it cool? Yes. So what about the key technology? 3D on 3D, what does that mean? We have been the first at Xilinx to use the 3D technology into the chip. 3D on 3D, probably everybody knows that 16 nanometer is FinFET Plus from TSMC is based on 3D technology as well. So 3D on 3D, it's what we are calling our 3D technologies from the FPGA using a 3D technology from the foundry. Allowing the MP SoC family. What is MP SoC? Multi-processing heterogeneous system on chip. Being able to combine FPGA technology with quad-core ARMs, 2 GPUs, security processor into the same chip. In order to deliver even more efficient application and to address broader applications. Tanya, you mentioned automotive, wireless, video, and broadcast on top of the telecom industry. This is what we're talking about here. So when we're looking at lower speed on the 25 gig, which type of applications are we talking about? Two examples here, a NIC card on the bottom and a kind of LAN on the motherboard on the top where you are directly connected to the processors with DMA IPs that you can directly share and access to the DMA of the processor and exchange a packet without having to directly from the memory processor, that's my accent.
I got it.
So intelligent NIC with packet processing, TCP IP offload, acceleration capabilities in order to be able to cope with the high demand applications that the data center cannot sustain from the connectivity perspective, allowing to double the server speed, meaning that today servers are all connected through 10 gig to the top of the rack switch. 25 gig, we can double the performance.
2.5.
2.5. Your math, finally.
I know, it kicked in.
And again, we are talking about having all the IPs required already available. You can stop to the Xilinx booth. We have 25 gig connecting to the Ixia platforms with our IP and with the Ixia IP into their platform. We already have, by the way, the 50 gig Mac IP and PCS as well as available.
He didn't tell me that yesterday.
That's new. So again, and the key technology drivers for the data center, power, latency, being able to have acceleration capabilities, and FPGAs are very, very good for acceleration applications. So I think that now we want to make a quick status. Where do we stand? Where are we into the standards and the relationship between Ixia and Xilinx?
Well, I think it's not a secret that the 400 gig standard is about 6 months late. We were supposed to have the first draft on the last meeting. We did not. And then the next meeting cycle, it's possible that we'll have a draft, but let's just say we won't. Then, so we're about 6 months behind. But we're working really hard to try to catch up. And the 25 gig standards is doing really well. We've adopted a initial draft, on 1.4 version. So it's coming along, and I think we've got it on here that by 2016, that's going to be done. And then the other one is later in 2016, the 400 gig.
Good. So Xilinx and Ixia, again, we started this relationship. We are partners in all the sense. I'm French, but everything is fine. So we started this relationship more than several years ago. And last year, when Ixia was really starting to a partner to deliver a 400 gig, we decided to partner together. We had the right technology, you had the right product and the right vision. That's what we decided to do. But what is the future? So you have seen the technology that we announced on the 16 nanometer. We have today technology on 20 nanometer as well and available in production. That's what the two companies are talking about. And we are here for the long run, isn't it? Good. Good, thank you. Yeah. So as a summary, let's try to close this wonderful duet.
Okay. I might just want to touch on, Ixia systems. We've interoperated with other switch vendors and also operators in the 400 gig E. And so, like I said, 400 gig, we've had it out for a year, and 25 gig, it's go see it today or this week.
So you're in production, ready to rock and roll.
Ready to roll.
So we talk about the partnership that we have. Solid partnership based on trust, technology, leadership on the two sides of the partnership. That's what is important in this industry. Trust, right technology at the right time for the right product and the right features. So on the Xilinx side, we had our 28 nanometer in full production since almost 2 years now. Our 20 nanometer, we have already parts in production. The full portfolio will be in production by the end of the year. We already announced our 16 nanometer, which will go to the terabit, and MP SoC with quad-core ARMs. So a lot of cool stuff coming on as well that will help the customers to reduce the cost, higher integration, and lower power. So any last words?
Go look at the world's first first and only 25 gig.
Then yeah, we have a picture. We have a
Hey,
picture.
there you go.
Come on.
But they should go there because they need to get a t-shirt, right?
Yes.
Okay.
But so, few things. This is what you will see on the two booths. Xilinx booth 729. For the lazy people, it's only 200 meters away. So you can make it, even the second day. Ixia booth, straightforward, just turn and it's in front of you. And by the way, you will have t-shirts. No t-shirts on the Xilinx booth, but we have cool things on the Xilinx booth as well. So, and most importantly, I think that this is very important that you understand the relationship between the two companies, why we need to interoperate and do those type of demonstration together, having our technology inside the testers, being able to demonstrate interoperability between IPs from one side and our IPs. That's the proof to the OEMs that they can use this technology and that we are ready for production. So I think that we want to open for questions.
We were so clear. I don't know if they have any questions.
So if you don't have questions, we have questions. So we mentioned two big numbers. Oh, Ixia mentioned two big numbers. So what were the numbers? Good, you have a t-shirt. And Xilinx mentioned a big number as well. What was it?
It's too big.
Let me repeat in French. 1.2 billion, 1 terabit. So you are getting a t-shirt from Ixia.
All right, we'll get you one.
So girls and boys, thank you very much for your time. Tanyana, it was a pleasure.
Thank you.
Thank you.